name is Jumshade. This is my Physics 1 lab report covering the fundamental principles of Newton's first and second law, covering constant motion. Here we are going to apply that an object in motion will stay in motion and remain constant unless acted upon by another force, also taking in Newton's second law of motion, or the momentum principle, stating that an object in motion will be dependent on the net force occurring and the mass of the object. The use of the initial conditions are measured from video analysis tracker, and then measuring a tennis ball that is rolling across the floor going to the left, and using a computational model that is developed in Python. This is my video and tracker. As you can see, the movement is very constant and linear, and while it's going, downward negative, that's just only because it is rolling towards the left on the axes that are set. You can definitely think about it as a positive velocity, of course, because this is my work that I used to get the ball's initial velocity. I took the initial position at t0, which would be 0.001, x is 0 for y and z, and then I got the next position, which is t1, or r1, and then my next time stamp, which is t1. My t1 is 0.033, and then r1 was 3.074, exponential to -2. I used the velocity formula, which was the change in position over the change in time, subtracted the R1 from the initial, and then subtracted T1 from the initial. And that got me my initial velocity, and then my last time of observation was measured here at the end of tracker, last time stamp. This is the glow script model. I used to see very constant, straight, nothing major, constant velocity throughout. And this is what I used to get my computational data. Now, in my coding model, I edited the initial position, which was 0.00100, and my velocity, which was -0.96, as we determined previously. And then I set t has to be less than 1.233, which was the last time we measured at any point. Modified the net force to 0 because no forces were acting upon it, and then updated the velocity formula and the position formula, respectively. Now this is the graph that takes the observational data that was obtained using tracker, and then comparing it to the computational data achieved in the Python glow script. As we saw earlier, for the most part it lines up very, very well, and any differences or anything that you can note were most likely minimal and are due to minimal outside forces, like friction, that are not present in the model. If we were to flip the axes, they would most likely remain the same. I mean, it would just be going up in the y direction. It wouldn't be anything different. And for your observations can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible to say how many pushes and pulls are added together to give 0 net force in the case you observe? If understanding this correctly, then, I mean, in the model nothing is acting on it, but realistically, in the observational data, yes, there is forces acting upon it, gravity and friction. So no, it's not really easy to you wouldn't be able to determine net force or the number of pushes and pulls in this model. And that's